When you go for your sim check, you want to demonstrate that you are competent, diligent, and cool under pressure. In my previous 3 videos, we discussed how that can be achieved by training a 5-step failure management structure for the 99% of the situations that do not have a dedicated memory item. A structure that you can tailor, and you should tailor in accordance with your company SOPs. Now you can download this free failure management structure at a320captain.com. Now we bring everything together and look at how I prepared for my upgrade and how I approach simulator preparation and studying of aircraft systems. Let me make a bold statement to emphasize a very clear point. I do not care how the hydraulic system works in normal conditions. I actually don't care how any system works in normal conditions. If all the lights are off, I'm happy. What I truly care about is what do I do if the hydraulic or any other systems fails. And this creates an essential shift in how I approach systems knowledge. I strongly believe that studying the systems from a failure management perspective is far more useful than reading the FCOM systems chapter until I fall asleep. You do not need a full simulator to train your management. You already know how to program the FMGS and you already know how to run the ECAM. If you struggle with that, there are some good FMGS and ECAM trainers available online, but these tools alone do not build your failure management performance. My name is Cristian Mandu. I'm an Airbus A320 captain, instructor, and examiner. On a320captain.com, I share observations from over 1,300 hours in the A320 simulator with practical insights to help you better prepare for your next sim check. Failure management is individual study that requires your FCOM, QRH, a performance tool such as the FlySmart, charts, a pen, and a paper. You don't need anything else to train your failure management flow. For today's video, however, I have prepared an online tool that I will use to present the situations. And at the end of the video, I will tell you how to access it for free so you can use it as a guidance to practice your own failure management using pen and paper. Because pen and paper is exactly what you have available with you in the simulator. In this video, we'll look at green hydraulic low level in cruise, a time available situation where you need to examine the QRH information with a critical eye, asking yourself, is that so? And you will see that you must be intimately familiar with the structure of some QRH procedure rather than trying to make sense of them for the first time in the simulator. And we'll also see how you can use your everyday flying to understand or sometimes discover that you don't understand the logic behind the QRH. We'll also look at an unextinguishable engine fire after takeoff, a time-critical situation this time, where your focus must shift immediately to the essential actions that protect the aircraft and the flight path, prioritizing the critical items and leaving anything non-essential for later, or skip it altogether. Different failures, the same structure. Practice the structure and be aware that it's unlikely that you will ever be able to apply everything in the structure in the exact order in a sim scenario. But if you practice it, you can adapt it to what is relevant to your scenario, and that's what will hold you together under high workload and stress. It is like the international standard atmosphere. I have never encountered all of those conditions in real life, but it is the reference for any performance calculation. When practicing failure management, always place yourself in a realistic operational context. I take flights I have actually flown and introduce a hypothetical failure because context matters. It shapes how we manage a situation. This example is based on a real 320 flight from Abu Dhabi to Dammam with Bahrain as destination alternate. Takeoff weight was 59.6 tons with 5.2 tons of fuel at takeoff. Weather at both destination and alternate was good, and according to the 80s, runway 34 right was expected in Dammam with a parallel runway closed by NOTAM. We are already in Bahrain airspace at flight level 160 as we have received an early descent. We have about 3 tons of fuel remaining and the approach into Dammam is fully set up, briefing completed, and there are no apparent threats to continue. At this point we get an ECAM, hydraulic green reservoir low level, which is confirmed on the hydraulic page. The aircraft remains stable, You don't lose any automation, there is no immediate threat to the flight path, and we have about 20 minutes to destination. Plenty of time to manage the failure. If you are already fully prepared for the approach, the estimated fuel on arrival in Dammam is about 2.2 tons. Let's see what can be applied from the 5-step failure management structure in a very scholastic, step-by-step manner, because I bet that you know with a green hydraulic reservoir low level, you will need to lower the gear using gravity extension, and that will bring you fuel penalty factors. But if you did not, you will find out following the structure, and that's what I'm going to demonstrate. Step 1. Select a safe flight path. Well, the flight path is already safe, but is there anything that we can do more? Seatbelts. Would you like your passengers to be attached to the Airbus? Yes, I would like that. So seatbelt sign on. Fly. Do we have any memory items? No memory items for this one. FMA. Autopilot 1 is okay. Flight director, okay. Auto thrust works beautifully with the autopilot 1 on channel 1. Configuration, we are in clean configuration as we wish. Normal low and overweight, no, we are not overweight. Navigate, do we have any land us up? No, there is no land us up. So our immediate decision would normally be to continue as cleared. However, given it's a short flight, one might consider a return, and that's absolutely fine, but a quick fuel awareness can challenge this option. In our situation, we took off with 5.2 tons. We burned 2.2 with about 3 tons remaining at the moment. A return would take roughly 2 tons without the takeoff phase and leaving about 1 ton on arrival, which is at or below the final reserve fuel, the legal minimum. So returning to base could compromise the legality of the flight. And considering that there are no threats affecting the approach into Dammam, the initial decision is to continue to destination, and what we can do is request to reduce the speed. So we continue as cleared and modify the speed. Communicate. Do we need to talk to the other pilot? Absolutely. We have to agree on the immediate navigation intention, and we also can say that we maintain the normal task sharing. ATC. You can tell ATC something like radar, call sign 123, we have a small technical issue. We would like to maintain flight level 160 and reduce minimum clean speed. Please stand by. Is there anything you need to tell to the cabin crew? No, not at this moment. There is no required to alert them at this point. And the fuel on block, we say it's about 3 tons of fuel right now. Time assessment. Is it time critical? Is it time available or time critical when landing gear extension? We know it's time critical when landing gear extension, but let's pretend we don't know that we have to do that. So we say we are in a time available situation. Step 2. Is it technical or non-technical? It is definitely a technical situation. And the question is anything to do before the ECAM? No, we don't have an OEB, we don't have paper checklist for this one, and we don't have system knowledge that we can apply before the ECAM. So nothing. Step 3, apply the chosen procedure. So you ask for the ECAM actions. In the FCOM, we have a small note saying that this alert is inhibited for the first 15 seconds of flight phase 5, which is actually from liftoff to 1,500 feet. So it's inhibited during the initial takeoff. PTU off, green engine 1 pump off, green engine 1 pump low pressure, then you get green system low pressure. Fuel consumption increased and FMS prediction unreliable. When? Fuel consumption is increased now or later? Is the FMS prediction unreliable now or later? We will need to clarify that. We continue with the secondary failures. You have wheel, your colleague goes through the wheel page and then he asks clear wheel, you say clear wheel. Fly control, go through the fly control page, you ask clear fly control, you answer clear fly control, and you come to the status. That's when you say stop ECAM. Do we have any resets? Do we have any paper checklist? For this moment and particular failure at this stage, no, we do not. So you say read status. Landing gear gravity procedure apply. Okay, that's good to know. It doesn't tell you where to find it or where to take this procedure from. Landing distance procedure apply. Fuel consumption increased. FMS prediction unreliable. Alternate yellow brakes with anti-skid. Slats flap slow. Cat3 single only. In operative systems, what is operationally relevant and what is not so relevant in the given conditions? Green hydraulic lost. Spoilers 1 plus 5. Well, on a 4,000 meters runway, that doesn't really matter. Cat3 dual. In Cavok weather, that doesn't really matter. Auto brake. Okay, we still have manual braking. Normal brake. Oh, we don't have normal braking, but we have alternate braking. Landing gear retraction. Now, that is the greatest threat in case of a go-around. Yaw damper 1. Remove status, ECAM actions completed. So you've gone through your status page, and what I do on my piece of paper in the simulator, I take and I write down the elements that are most relevant for that particular scenario. The landing gear retraction is the problem as it impacts us in case of a go-around. So it's critical when landing gear gravity extension. Step 4, situational awareness update. Time, weather, and runway. If you do your homework properly at this very stage, everything else is going to be easy. Do we have a summary? No, we don't have a summary for this situation. We need to do performance. So let's do the performance with the FlySmart software. FCOM, small print, level 2 and 3 information if time available. Yes, we do have time available now. At the status page, the landing gear gravity procedure apply, a small note referred to QRH landing gear gravity extension. And the FMS prediction unreliable, it is explained in the level 2 information saying disregard the FMS fuel predictions and refer to the QRH Fuel Penalty Factors ECAM alert table in order to find the applicable fuel penalty factor. So now we know that we have to apply the landing gear gravity extension from the QRH, and we have to refer to the fuel penalty factors also from the QRH. Let's do that. The landing gear gravity extension is given for many situations. So you need to know the structure of this in order not to waste time by making sense of the procedure at that very moment. So you would go straight into the all other cases. Gravity gear extension hand crank, pull and turn. Rotate the handle clockwise 3 turns until reaching the mechanical stop, even if resistance is felt. Afterwards, landing gear lever down. Gear down indications, if available, check. The landing gear LGCIU 2-fold or brakes system 1 or 2-fold alert may be spuriously triggered after a gravity extension. So you can expect these additional failures as spurious following the gear extension. Read the notes. If successful, do not reset landing gear gravity extension. If unsuccessful, landing with abnormal landing gear procedure apply. Refer to the QRH landing with abnormal landing gear. In our practice situation today, we will not get into the landing with abnormal landing gear. We'll have other issues. So let's take a look at the other small print procedural items that we need to refer to. The QRH fuel penalty factor. The A320 QRH lists the following fuel penalty factors. 180% penalty for the landing gear down and 15% penalty for the gear doors open. So that will be the normal flow 100% plus 180 plus 15% equals to a total fuel flow of 295% of the normal value, almost triple. That is impossible. Let's do some critical thinking. What do you do in the sim? Do you believe what the QRH tells you or what you actually see on your instruments? And more importantly, what does your examiner expect? Blind compliance or critical thinking supported by real data? Fortunately, the answer is already in the QRH itself. In a small QRH note, it's clearly stated that the flight crew must still compute and monitor the actual fuel consumption. MEL. We need to check the MEL for a possible no dispatch situation. That is absolutely obvious in this particular scenario, but let's do it anyways. Clearly stated, no dispatch. So let's put some numbers on our times. In a clean configuration at green dot speed, FlightSmart gives about 2,140 kilograms per hour. That means a 30 minutes final reserve of roughly 1,070 kilograms, which matches the OFP almost exactly, 3 kilos difference. Now, introduce the landing gear gravity extension, and we insert a 30 minutes non-standard configuration in FlySmart, the final reserve increases to about 1,790 kilograms. That's an increase of roughly 68%. If I apply that same factor to the alternate fuel from the OFP, which is 900 kilograms, I get approximately 1,500 to 1,600 kilograms. So what does this mean operationally? In the event of a go-around, I can still proceed to the alternate and land there with about 600 kilograms remaining. Now that's roughly 10 minutes of fuel. Not comfortable, but doable. Now let's translate this into a real decision. If we land, fine. If we go around, we don't guess, we check the actual fuel flow, and if the numbers we see are in line with or better than what the flight smart predicted, then we have a validated picture for our endurance. At that point, we can request radar vectors for a straight-in ILS runway 12 left in Bahrain. And if we want to be even more diligent, we can cross-check this with a flight smart as well using the plan for alternate function with a non-standard configuration inserted and even doubling the distance between Dammam and Bahrain to 100 nautical miles. It actually is less than 50 miles. We still get a fuel requirement of about 1.4 tons for roughly 30 minutes of flight. So again, the picture is consistent. And Airbus is very clear on this. In this type of scenario, the QRH reminds us that the crew must compute and monitor the actual fuel consumption. That does not mean relying on a single method. We can use tools like FlightSmart to compute, estimate, and plan, but in the event of a go-around, what really matters is what you see on your instruments. The actual fuel flow indications become the reference. This creates a completely different situational awareness compared to taking the QRH fuel penalty at face value. The QRH gives you a conservative reference. But the aircraft tells you what it's actually doing. So the question is not whether you follow the QRH. The question is, do you follow it blindly? Or do you understand it in context and support it with other data? That's airmanship. Airmanship based on critical thinking, something you can practice at home. And that's what will reduce your stress and boost your confidence in the simulator. Step 5, DODAR and FORDEC. And this part is actually simple if your situational awareness is solid. Start with your status page. That gives you the primary problem and the operational implications. Clear, concise, already structured. By definition, the inoperative systems tell you what is not working, but I'm a pilot and I'm more interested in what is still available. So, primary problem, green hydraulic reservoir low level. Operational implications, we are now Cat 3 single with alternate braking and with anti-skid, so we can taxi normally. That's a good opportunity for you to revise the braking systems at home. We need to apply the landing gear gravity extension, and once the gear is extended, it cannot be retracted, which leads to a significant fuel penalty and a fuel mayday in case of go around. Performance. We have calculated with flaps 3 for runway 31 right in Dammam. Landing distance required 1,461 meters out of 4,004 meters available. Cat 3 single means a minimum required RVR of 175 meters and a current visibility is 10 kilometers or more. Assistance. ATC. They need to know that in case of go around, we declare a fuel mayday. Other than that, it's normal landing and we taxi to the gate. Cabin crew, normal landing, no need to alert them. Maintenance is required as we are no dispatch after landing. Options. Dammam, 16 left, 34 right, ILS on both sides, 4,004 meters, parallel runway is closed by NOTAM. Option 2 is Bahrain, 12 left, 30 right, ILS on both sides, 3,964 meters. Risks and benefits. Dammam is destination, Bahrain is company destination, maintenance available both, excellent weather. Any risks? No, not really. We could quickly call or text MCC with our options, but I'm quite sure they would like us to continue to the destination. Decision. Decide. Dammam ILS runway 34 right. Assign, execute. Time critical when landing gear gravity extension. Pilot monitoring. Does an ATC needs briefing? For example, Dammam, call sign 123, we have a hydraulic issue, request radar vectors, ILS 34 right, will be ready for approach in 5 minutes. It's going to be a normal landing and we taxi to the gate. Please advise our company that we require maintenance after arrival. Keep normal task sharing and then we continue with the senior. For them, it's a normal operation and it's not required. Passengers, also normal operation, no additional PA required. Normal briefing was done, and briefing updates are done while maintaining normal task sharing. Threats. Main threat is non-standard landing gear gravity extension QRH procedure with fuel penalty and potential spurious landing gear LGCIU 2 fault or brake system 1-2 fault. Fuel mayday if go around, and light aircraft does not want to decelerate because of less induced drag, so I will use the speed brake as required. The how, before and after landing. Pilot monitoring has the landing gear gravity extension procedure ready. We do the approach checklist. Normal configuration sequence will be flaps 1, 2, gravity extension, flaps 3. Gates, I aim to be fully configured by 1800 feet and stabilized at 1500 feet. Manual alternate braking with anti-skid, vacate runway first left on hotel, and in case of go around request immediate right turn. If we consider diversion, we clean and check the fuel flow, then assess the situation. Diversion was calculated with fuel flow at green dot with equal or less than 1,800 kilograms per engine. Company was informed by ATC. Revise or check. Quickly go through everything we have done. Any changes in the diagnose? No. Status page is the same. Options, Dammam and Bahrain. Risk and benefits, assess decision, continue to Dammam. ATC is advised, senior not required, passengers not required. FMGS plus briefing updates have been done and company knows about us. What did we miss? Are there any new factors? Not in this scenario. So we can say we are ready for approach. With all explanations included, the entire failure management took just over 14 minutes. Most of the work happens in step 4, exactly what it should, because that's where you build your situational awareness, and once you understand what's going on, the DODAR FORDEC becomes straightforward. So the real question is, how long does it take you to run your steps? I have added timestamps in the online tool so you can see where your time goes and start improving it. Now, let's take the same structure and put it under some pressure. You are on final, at 1000 feet the tower calls you to go around. A rejected takeoff with multiple tire bursts has closed the runway for at least 20 minutes. You have 2.2 tons of fuel on board, gear down, and you cannot retract it. The QRH suggests you have 22 minutes endurance, but your alternate Bahrain is 25 minutes away. If you want a deeper breakdown of this exact scenario and the QRH fuel penalty factors, I have made a dedicated video where I compare the QRH with FlightSmart, simulator behavior, and the real aircraft observations. Link in the description below. If you follow the QRH blindly, stress spikes instantly, your chimp becomes pilot flying and rushes into an emergency landing somewhere. But if your structure is solid, it holds your Einstein in command. Let's run it. Okay, so here is your new context. So let's apply the 5-step failure management structure. Step 1, select a safe flight path. Seatbelts are already on, memory items no, FMA, autopilot okay, flight directors okay, auto thrust on channel 1 okay. Configuration, we have the landing gear extended and we are in normal low. Navigate, do we have land us up? No. Immediate nav intention, we need to require radar vectors for a straight-in approach, runway 12 left in Bahrain. Communicate, always communicate your intentions with the other pilot, and we need to declare a mayday to the ATC. Radar, call sign 123, mayday, 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 fuel. We require radar vectors for a straight-in approach, ILS 12 left in Bahrain. And we are ready to pass you the following information. Fuel on block 1700 kilograms, endurance about 30 minutes, POB 125, and no dangerous goods. Cabin crew is not required to talk to them at this very moment. Time assessment, you are time critical. Step 2, is it a technical or non-technical situation? It is non-technical. The runway has been closed, but it's nothing you can do about it. Step 3, apply the chosen procedure. There is no procedure per se, but if your company has diversion guidelines, you can use that. Step 4, situational awareness update. Summary, not applicable. Performance, we need to do the performance calculation, or if your company is flexible and open-minded enough, We can say previously we needed less than 1500 meters and we are going on a long runway. I'm happy if we skip it. I would skip it in this case. FCOM, no change from the previous, skip it. MEL, no change from the previous, skip it. Your time available is about 30 minutes with 1,700 kilograms of fuel assumed on board. Weather, landing capability with Cat3 single 175 meters. We are going into CAV-OK, no factors, and we have just done our landing distance performance calculation, coming up with a landing distance required 1,485. DODAR and FORDEC. Diagnose or facts. Facts, runway is closed, requiring us to go into diversion and fuel mayday. Performance, required 1,485 meters, going on a runway 3,657 meters long. Assistance, we need radar vectors from the ATC and the cabin crew. We need to inform them via NITS or company procedure about the diversion. Maintenance, we can deal with them later on. Options, Bahrain is our only option at the moment. Risk and benefits, we are in fuel critical situation, so we are monitoring carefully, proceeding for a straight-in approach. Decision, Bahrain, happy with that, I'm happy with that. Assign, ATC, radar, call sign 123, mayday fuel, request radar vectors, ILS 12 left, we'll be ready for approach in 5 minutes. It's going to be a normal landing with taxi to the gate. Senior, you have to give a NITS briefing or follow the company guidelines to inform the senior about the diversion. If you give a NITS briefing, you can do it over the intercom or you can do it on the flight deck, depending on the time available. Here, I would prefer to do it over the intercom. I will always start by making sure the senior's Einstein is ready to receive the NITS briefing. Hey, how are you? Everything okay back there? Look, we have a situation here that requires me to give you a NITS briefing. Are you ready to copy? Yes, Captain, I'm ready to copy. Nature. Runway in Dammam has been closed due to an operational issue over there. Additionally, we have a small issue with our landing gear. We cannot retract it right now. Intention, we are diverting to Bahrain. Time, we will be landing in about 25 minutes. Special is going to be a normal landing. We taxi to the gate and it's going to be noisy due to the extended landing gear. Please read back, and the senior reads back to you. And agree with them on a time frame when you will do the PA. Let your senior brief the other crew before you make your PA. Passengers, ladies and gentlemen, once again from the flight deck, this is the captain speaking. Unfortunately, we had to discontinue the approach in Dammam due to the runway getting closed in front of us due to some operational reasons at the airport. Our intention is to divert now to Bahrain. We will be landing in 30 to 35 minutes. It's going to be a normal landing, and due to a small technical issue with our landing gear, we have to keep it extended. That's why it's a bit noisy, but everything is under control. Please strictly follow the cabin crew instructions and I will come back with more details after landing. Thank you. Update the FMGC preparation and the briefing. I would give the flight controls and the communication to the pilot monitoring. I will take care of the FMGS preparation myself, and then we restore normal task sharing and we do the briefing in accordance with the company SOPs. However, main threats are mayday fuel, and it's really very critical in case of another go around. We better get it right from the first shot. And I would also keep an eye on the fuel on block versus the actual fuel flow to update the time available. How's we need to do the approach checklist. It's going to be an abnormal configuration sequence as we have the landing gear extended already. And my gates are to be fully configured in flaps 3 by 1,800 feet, stabilized at 1,500 feet. Manual braking, vacate conveniently to the right and taxi to the gate. Company, we can ask the ATC to inform them, or we can send a quick ACARS message. Revise or check. Diagnose or facts, done. Options, Bahrain. Risk and benefits, discussed. Decision, decide. Still happy with Bahrain? Yes, absolutely. Assign. ATC knows about us, senior knows about us, passengers are informed, FMGS plus briefing is done, company knows about us. What did we miss, or do we have any new factors? You can enter your time and see how long it takes you to do that. Ready for approach. Let's now place the same structure into a very different context. This time, the challenge is not fuel planning, endurance, or building a picture over several minutes. This time, the challenge is time criticality. In this example, we look at a bird strike at V1, where if you follow the ECAM blindly, you will most likely crash. Always think before jumping into the ECAM. We are taking off from a slippery runway. The speeds are 145, 153, 154, And straight away, what matters here is the gap between V1 and VR in case of an engine failure at V1. Packs are off and one engine SID is straightforward, maintain runway heading and climb straight ahead for 25 miles to MSA. Weather is CAV-OK and light winds. V1. Step 1. Select a safe flight path. Seatbelts are already on. Fly. Any memory items? No, just the engine failure drill. Rudder, rotate slowly, trim, autopilot in, heading, and consider toga, but maybe not a good idea in this case. Autopilot is in, flight directors are fine, and auto thrust channel 1 is okay. Configuration: maintain flaps 1 and flight control low is normal. Now navigate. We have a red LEN ASA, but first we maintain runway track, the engine out SID, as the safest immediate path until a clear plan is established. We have a few options here. Continue straight ahead, then position for the parallel opposite runway, or fly an 80-60 procedure and return to the same runway opposite direction, or option 3, fly a short traffic pattern and return to the runway already prepared in the FMGS. What would you prefer? Do you have any company guidance? For this scenario, I would choose a left-hand side traffic pattern at 1,500 feet above aerodrome elevation. And I communicate this with my first officer, and I take over controls and communication. ATC. Radar, call sign 123, Mayday, 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 engine fire, request visual left traffic pattern for the departure runway, standby. Approved. Cabin crew, company specific emergency call out, but for example, cabin crew, emergency landing, cabin crew, emergency landing. This is a time critical situation. So step 2, is it technical or non-technical? Technical, but before touching the ECAM, stop and think, because blind execution here could cost you the only running engine and the aircraft. Step 3, apply the chosen procedure. Instruct your pilot monitoring. Do not follow the ECAM blindly. The engine on fire is your only running engine. Skip that ECAM actions and secure the failed engine. Keep the burning engine alive. Step 4, situational awareness update. At this stage, there is very little to reassess. Most of the decisions have been already made. Performance, no real options, we are committed, overweight, maximum braking if needed. FCOM, no time. MEL, no time. Time is critical. This is driving everything. Weather assessed only to the extent that it affects the immediate landing. For example, in LVO, I would land below the minima with auto land, because my priorities are clear: safe, legal, on time. Runway is already selected, we stay with the plan. Step 5, diagnose. Engine 1, unextinguishable fire. Engine 2 failed with damage, unrestartable. We are overweight for landing. Options: departure aerodrome, decision, immediate return, assign, execute. I still have control and communication. Reinforce the intentions with ATC if required. If time permits, a quick senior cabin briefing on the intercom. Nature: unextinguishable engine fire, intention, immediate return, time less than 10 minutes, special. Keep the cabin secured and expect standard emergency callouts, possible evacuation. Passenger announcement: calmly or skip it. Ladies and gentlemen, from the flight deck, your captain speaking. We have an engine fire and will return to the departure aerodrome. We will be on the ground in approximately 10 to 15 minutes. The situation is under control. Please strictly follow the cabin crew instructions. Thank you. FMGS preparation. Very little to do. The approach is already prepared in the secondary flight plan. I would ask the pilot monitoring to activate the secondary, sequence the flight plan, and a direct to FAP with radial N. The FMGS is normally followed by an approach briefing. Companies offer extensive guidance on how to do these briefings, threat-based or otherwise. However, I have found very little guidance on how to do an essential briefing in a time-critical situation, where you simply do not have time to complete a standard, thorough briefing. Would you go and check chart validity? Well, I hope not. Of course not. You need to chop that away. What else would you chop? Maybe a better question is, what would you keep? What is that absolute minimum you need to consider and brief in a time-critical situation? You may need to develop your own structure. For my upgrade, I developed my essential briefing. First, runway and approach time. Then I use the acronym CART-E, standing for landing configuration, auto brake, use of reversers, taxi, and emergency callouts. This is my bare minimum, but you should develop your own solution in accordance with your company SOPs, if any guidance exists. Any briefing should focus on the relevant threats. In our case, unextinguishable engine fire and overweight landing. How do you manage these threats? Land ASAP and apply the overweight landing checklist. Now, this is a checklist you must know. And I mean know it, not read it. You glance at it if you have time, but if you don't have time, you know it. I'll make a short parenthesis here to explain why I believe it is important to know some procedures almost by heart. I had a situation with a 4,000-hour first officer, an ex-captain on a small jet, who completely froze during a challenging weather landing in Luton. I had to take over the control and perform a single pilot go-around from 30 feet. He came back on downwind and he didn't even know what happened. He was completely out. In a situation like this, with a major unextinguishable engine fire, an inexperienced pilot can understandably freeze. I froze during my first encounter with severe turbulence during my 737 line training years ago. I was 27 years old and that happened during my first airline job, early stage of line training right after flight school. These are the realities of human performance under stress and high workload. I have seen it happen to experienced pilots as well. With a decreasing level of experience we sometimes see today, as a captain, I prepare for the worst. My colleague being overwhelmed with a chimp taking over and triggering a fight, flight, or freeze response. I choose to know the core structures of these procedures by heart, so even in the worst case scenario, if my colleague is temporarily incapacitated, I can still apply them safely. Know the essentials of the overweight landing checklist. Packs off or supplied by the APU, speed selected at VLS, flaps full, and smooth landing. But more importantly, you must think about how you apply it in this context. Think, again, during your failure management preparation at home. Engine 1 and APU bleed supply on the same duct. If you use APU bleed, you risk inhaling fumes from a duct possibly contaminated by the burning engine 1. You cannot feed pack 2, so I would keep the packs off. Now, the how before and after landing. We stay as close as possible to the standard 1,500 feet traffic pattern, but we adjust it to minimize the demand on the burning engine by delaying the final configuration. The gates are as follows. Maintain flaps 1. Before turning base at 1,500 feet, I disconnect the autopilot and the pilot monitoring advises the cabin crew emergency stations, or the company-specific callout. On base, flaps 2, and before turning final, gear down, flaps 3. At 600 feet, flaps full, I aim to be stabilized at 500 feet, followed by the brace, or company-specific callout. Speed is then selected at VLS, and there is no go-around, really, and we do not use the reversers during the landing. Once stopped on the runway, I set the parking brake, call attention crew at stations, and request the emergency evacuation checklist. Company, later, review, diagnose, no change. Options, this is the only one. Decision made, ATC, cabin crew, passengers, informed. FMGS updated, minimum essential briefing completed. What did we miss? Any new factors? How long does this take you to do? Clear to land. After landing, you apply the emergency evacuation in accordance with your company SOPs. When you train the structure and understand the procedures in context, your Einstein remains connected. And that's what keeps you in control, competent, diligent, and cool under pressure during your sim checks. You can now access the failure management online tool by logging into your account on a320captain.com. Use this online tool to develop your own structure with pen and paper. That's what you have available in the simulator. Thank you for watching, and I wish you many sim checks with no stress and safe flights.